Okay, kita akan discuss timer operations and programming. Okay, so in this video, we will discuss only the theory of the timer operations. Programming will be next. Okay, will be next. Timer, basically timer is based on the counter, digital counter. So if you have digital counter, if you apply clock and then it will count up, right? It count up until maximum. For example, if you have a 4-bit counter, so the 4-bit counter will come from 0, 1, 2, up to 4, 15. And then when you apply another clock, then it will toggle or roll off. Sorry, not toggle, roll off to 0. And then we'll carry on, count up in that manner. So from that, we can calculate the time taken, or time total time, or time taken for that count. So total time is equal to C max minus C RST or reset plus with 1 multiply with T clock or the period of the clock. Period of the clock. So for example, if C max if actually is a final count, C rest is a start count. Final, we can say final count minus with the start count plus with 1 multiply with T clock. Okay, so that is the time delay that taken. If you understand this, okay, the stupid digital counter, so you can understand the timer operation as a whole. Okay, basically timer, we can have a number of operations. We can have the first one, the time-based mode, time-based mode operations. We can have counter mode operations. We can have the pulse width modulations mode, and we can have the input capture mode. Input capture mode. So what is the time-based mode? Time-based mode, actually we have the, okay, as shown by the block diagram, right? So we have the internal clock. Of course, the time-based, we use the internal clock because we need the fixed interval clock to support the counter. So the counter is provided with the prescaler or the visor. In other words, it's the visor. So if you clock, let's say, if 1 meg, you can divide it into, example, you can divide it into, let's say, 100 kilohertz, right? 100 kilohertz by setting the prescaler, by setting the prescaler. Okay, so then it's that the counter count feed to the prescaler, feed the clock to the counter count up until the count is equal to the auto reload register. So the auto reload register determine the maximum count of the counter. So when it's equal, then the counter will be reset and the count will restart, count up again as the digital counter. And next, when it is equal, the UG will be set, or the flag. It will flag the controller, saying that the count is overflow. So if it is in polling mode, so we need to check, the UG already set or not. But in the interrupt mode, then it will generate the interrupt, and then the interrupt, we can have a code to serve the interrupt. Okay, the next one that we have, so here we can see that by using it, right? So you can see here the counter will count up until the end, and which end is the auto reload register, right? Or PR register. Then when it's equal, then the flag will be set, right? Then it's carry on in that manner. Okay, the second one that we have a counter. For the counter, the application usually to count. As example, we count the number of car, or we can count the number of boxes, to generate to activate the flancher to push the box into the main box, for example. Right? That is the applications. So we have the external trigger. Of course, the external trigger is a sensor that detect the number of the box. So we can have the each detector. So either the counter, right, generate the pulse when it is positive trailing or negative trailing. Again, we have a prescaler, again, and then feed to the counter. But normally the prescaler in the counter application we set to 1. Yeah, so no divide. Feed to the counter. Just like before, when the counter equal to the auto reload register, then it will reset the counter becomes 0, and at the same time UG will be set. Again, depends on either the mode of operation is polling mode or in interrupt mode, right? So it depends on that. So UG will be detected either by polling or by interrupt. The next one that we have is the pulse width modulations. In pulse width modulation, we have auto reload register and we have capture compare register. Okay, so when in this case also we use the internal clock, because pulse width modulation we need the fixed interval clock, right? So feed to the prescaler again to divide the frequency, and feed to the counter, so the counter count up in that manner, right? Count up until equal to the auto reload register. Then we reset the counter equal to auto reload register, and then it reset the counter. That's all, right? For the for the auto reload register. But for the capture compare register, when counter less than the what we call less than the capture compare register, the output will be 1. Yeah, the output will be 1. But if the counter equal or greater than capture compare register, then it will be 0. So for that reason, capture compare register determine the duty cycle. Determine the duty cycle. So the duty cycle is depend on capture compare register over auto reload register. Example, if auto reload register is 1000, capture compare register is 100, then the duty cycle is 10%, 100 over 1000. So you can see that timing diagram that I showed there. Okay, so if the counter equal to the CCP, right, then the pulse changing to 0, right? But if the counter less than CCP, or combination CCP, Federation Russian Projections. So the what the pulse become 1. But when the counter greater or equal or greater than CCP, the output become 0. And when counter equal to PR, you can see the red color there, right? Then the counter change to 0, reset to 0, and at the same time, then the output become 1, because counter less than CCP, right? CCP. That is the way how the CCP or the pulse width modulations operates actually. Okay, clear. That is the pulse width modulation. So we can see that in the time-based mode, counter mode, we use only auto reload register, right? Auto reload register. But in the pulse width modulation, we use another register, capture compare register. Next, we have the input capture mode, or input capture operations. All right. But same with the pulse width modulations, we use the capture compare register. But in this case now, we have the counter that drive by the internal clock or fixed interval clock, feed through to the counter through the prescaler, to count up, and then when the counter is overflow, when counter equal to auto reload register or some sort like overflow, so it will reset the counter and generate the UG. So UG normally we use to count up, to count up the loop. We use another register variables, say loop. So loop determine that the counter already overflow, right? So that is the parts of auto reload register. And for the capture compare register, when there is an external trigger, there is external trigger applied to the module, so the value of the counter will be copied by hardware to the capture compare register. So the microcontroller can copy this capture compare register and use it. Right? So that's all about the capture compare register. It's will copy the value of the counter when there is an external trigger applied to the input capture module. Okay, so now example. This is example. When we start, we apply ATR. So at the time the value the counter we copy the value of the counter, right? Copy the value of the counter because we set the each detector at positive, positive trailing. Right? See, positive, changing to positive, then CCP will contains or copy contains the value of counter or copy the value of counter. So this is the start value, the start value. And next, because of the counter, the value of the counter more than the auto reload register, then it will change to 0, reset to 0, and loop will increase by 1. Next, the counter will count up, reset to 0, right? Reset to 0, and loop become 1. Then after that, then assume that there is an ETR, external trigger. So the value of the counter at the time will be copied. So this is second value. So we can use this value now. Right? In general, the formula is become like this. And the time taken, forget about the time counter. The count is equal to 2 time loop. You see, we have 1 and 2 loops here. 2 time loop. So how many count per loop? Example 1000. Okay, so 2 times 1000 minus with the start loop plus with the end loop. So that is the formula. You can see in the slide later on. This is counter. I think number 5. I think. Okay, this is the formula. You can see that the formula is equal to L multiplied by O, loop multiplied by O number of count, plus with if n minus with start. Right? This is the formula. So from that, then we multiply with the period taken. For example, 1 count is equal to 1 microsecond. So we got the time. From that we get the time. Okay, this is, so you can see how I write code later on in the slide. Okay, so we can see that the way the applications of the input capture mode. Normally we use it in, for example, we can use it in determine the speed of the bullet, for example, the speed of the runner, marathon runner. So in this case, then we can get the difference between all the runners, right? The first runner, so the start it become the of course the start we need to trigger lah, by manually, maybe by switch when, and then the second one, the second one is detect by what, when the sensor, when the runner pass through the end point and so on. Okay, so that is the application of the timer. So I already produce you the video later on. You can check the video for that. Video how to write code for that. Okay, bye bye.